All right, welcome back. We're surrounded by these incredibly powerful AIs, but how do we actually make sure they're working for us, not against us? So today, we're going to dive into a critical piece of that puzzle, AI alignment. It's the art and the science of teaching an AI to be helpful and safe. So it all boils down to this one big question, right? How do we get these super smart language models to line up with what we humans actually want? How do we teach them what good even looks like? And the main way we do this? We basically hire an AI to act as a judge.
Now, in the world of AI, this judge has a technical name, a reward model, or RM for short. Its whole job is to look at what another AI says and give it a score. A high score means, hey, good job, do more of that. And that's how we guide the AI to become more useful. Sounds simple enough, doesn't it? But here's where we hit a snag. What happens when you put all your trust in just one single judge?
And that, right there, is what we're going to call the single judge problem. It seems like the easy path, just having one reward model making all the calls. But believe me, it is loaded with traps. So, when you lean on just one judge, you run into three big problems. First, generalizability, or lack thereof. I mean, think about it. You wouldn't ask a math whiz to judge a poetry slam, right? Same idea here. An RM that's great at code is probably terrible at judging creative stories. Second, the cost is just insane. If you use the biggest, smartest model as your judge for every little thing, you'll go broke. And third, and maybe the trickiest one, is this: over-optimization. The AI gets really good at, well, gaming the system. It learns how to exploit the single judge's quirks and biases to get a high score, which isn't the same as actually getting better. Okay, so the folks building these things knew this was a huge issue, and their first stabs at fixing it, well, they made sense on paper, but in practice, not so much.
The first big idea was, hey, let's just create a committee of judges. They called it an ensemble. But can you imagine asking every judge their opinion on every single thing? It was just way too slow and cost a fortune. So then came Laser, which was supposed to be a bit smarter about switching between judges. The problem? It was kind of slow in the uptake and would often get stuck listening to the wrong expert. It was clear we needed something a lot more sophisticated.
All right, so those early attempts didn't quite cut it. And that brings us to a much smarter solution, something called BayesianRouter. And trust me, this is where things get really, really interesting.
This quote from the paper really hits the nail on the head. So that offline learning stage, just think of it like a study session. The system is preparing, figuring out which judges are good at what. And the online adaptation stage, that's game time, when it's making smart choices in the moment. It's this two-part hybrid approach that's the real game changer. So, to put it simply, BayesianRouter is like the student who does all the homework before the big test, but is also smart enough to adapt to surprise questions on the fly. It's the best of both worlds.
Okay, so we know it's a hybrid system, but how does it actually work? Let's pop the hood and take a look.
It really just comes down to these two key parts. First, you've got the offline training, where it learns who's good at what. And second, there's the online selection, where it uses that knowledge to pick the perfect judge for whatever comes its way.
So, step one is the offline router. And the best way to think about this is the homework phase. The system crunches a ton of data, figuring out, okay, this judge is a rock star at math problems, that one is amazing with history questions, and this other one is a genius with poetry. What it's really doing is building this incredibly detailed map of its team of judges, figuring out who's the best pick for any given situation.
Okay, so once the homework is done, we get to step 2, the online router. And this is the smart team captain in action. A new question comes in, and the system uses its homework to pick the best specialist for the job. But here's the really cool part. It doesn't just make a pick and call it a day. Nope, it watches what happens, learns from the outcome, and constantly fine-tunes its strategy in real time. It's always getting smarter.
All right, so the idea sounds great, right? A system that studies up beforehand and then adapts on the field. But does it actually work? I mean, what do the numbers say? Let's dive into the results.
Okay, so check this out. On a pretty standard benchmark, the results are, well, they're pretty clear. The best you could do with a single judge gets you a score of about 61.8. That older system, Laser, actually did a little worse. But look at BayesianRouter. It jumps up to over 63. That's not just a little better, that's a real, measurable win. Smarter routing clearly leads to better performance.
So when you boil it all down, the big takeaways from these tests are super clear. First off, it just flat out beat everything else. Single judges, committees, the old Laser system, all of them. Second, and this is a huge deal, it did all this without costing any more than the simple single-judge approach. And finally, they proved that the real magic is in that hybrid approach. When they try to use just one part of it, the performance tanked. You need both the homework and the smart captain.
Okay, I want to zoom in on this one detail, because for making this work in the real world, it is everything. I'm talking about O of 1. For those of you who aren't programmers, that basically means constant time. It means no matter how big your committee of judges gets, whether you have 10 or 1,000, the system only ever has to call on one of them for each question. This is the whole ball game. You get the benefit of a huge, diverse panel of experts, but you only have to pay for one of them at a time. That's how you make this stuff practical.
So, after all this technical talk, why does any of it really matter? It matters because if we want to build AI that's actually helpful and safe, we have to nail the feedback process. A system like BayesianRouter isn't just a small improvement, it's a huge step towards creating AI that we can trust, and it's a method that can actually grow with the technology.
And that kind of leaves us with one last big question to chew on. So, we've figured out a much smarter way to pick the judge for the job. But what happens when the AI students start getting way smarter than their judges? As the AI we're training gets more and more powerful, how do we make sure our panel of AI judges can actually keep up? Figuring that out, that's going to be the next massive challenge in the world of AI alignment.